Greetings of the day, dear students. Now today in this class, in this video, we are going to discuss about the star to delta transformation. And one more important point, dear students, you first watch the delta to star transformation and then later watch the star to delta transformation, because while converting from star to delta, you need to understand before that delta to star transformation, right? So here we will start how to convert the given star into delta, and in the previous video we have discussed what do we mean by delta connection and what do we mean by star connection, right? So how to transform the given star to delta, and in this detailed step-by-step manner we will see with the formulas, substitutions, calculations, and final answer, right? And also we will discuss the summary of star to delta and delta to star transformation. In this video we will see the summary, and also in this video we will discuss the examples how to transform the given star to a delta, right? So this is what we are going to learn in this video. But I request you once again, before starting star to delta transformation, you first complete delta to star transformation first, right? Now, as already we have discussed the delta to star transformation, right? For a given delta, for a given delta, if you want its equivalent star, if I want R1, I am multiplying these two, R12 into R31 whole divided by, the denominator is same as we discussed earlier. The denominator will be R12 plus R23 plus R31. Similarly, if I want R2, I am multiplying these two, the resistors connected, the two resistors connected at node 2, right? So R12 into R23 whole divided by R12 plus R23 plus R31. Similarly for R3 equal to multiplication of these two resistors which are connected at node 3, R23 into 31 divided by R12 plus R23 plus R31. So these three are required first. The moment you are asked to derive or do the star to delta transformation, okay, first from delta to star you should write, we know that R1 equal to R2 equal to R3. From these three formulas only we are going to find out if R1 is given, what will be the value of R12. Our target is how much will be this R12 value. That is what we have to find. You know R1, R2, R3. Now what will be this value of R23? Now what will be the value of this R31, right? Yeah, let me see in a step-by-step manner. Observe, this is all about rearranging the terms. Just you will understand this here. Now you simply multiply R1 and R2. What you have to do, dear students? We have to multiply. You know R1, you know R2, you know R3. Okay. You know already, you know R1 and you know R2 and you know R3. In the first step, simply multiply R1 and R2. You continue the same step for remaining 2. That means if somebody have taken in terms of 1, 2, 3, if they have taken RA, RB and RC, you have to find RA into RB. In the second step, you please find RB into RC. In the third step, you please find RC into RA. If you have taken the notation in terms of 1, 2, 3, dear students, you please first find R1 into R2. In the second step, you take R2 into R3. In the third step, R3 into R1. I repeat again. These three are important. Already you know formulas for R1, R2, R3, right? Yeah. Now after finding out these three, let me rearrange. If you observe, in all the three, the denominators are same here. Numerators are changing. That observation you make. Now you just simply add those three, R1 into R2 plus R2 into R3 plus R3 into R1. You just you add these all the three terms. Dear students, for all the three terms denominator is same. Observe, in all the three terms denominator is same. That means while doing this step, the denominator is same. R12 plus R23 plus R31 whole square, and the numerator the first term plus this second term plus third term. Clear? So far clear? Right. Now from the numerator part, you just take out R12, R23, R31 common. Let me take out R12, R23, R31. For example, from the first term, we are having R12 square. If R12, 2, 3, 3, 1 are taken out common, what will be left out? This one will be left out. In second term, which term square we are having? R23 square term we are having. Already taken out common, 1, 2, 2, 3, 3, 1. So what is left out? One more term, R23 is left out. R23 we will get. In the third term, which square factor we are having? R31 square. We have taken out common. R12, 2, 3, 3, 1 is taken out common. What is left out? Because of square, R31 is left out. This step is very, very important. If you got this step, then everything is easy for you. Clear? Now, if you observe, denominator square we are having. In the numerator part, what we got now? R12 plus 23 plus 31. So this entire term and one of the term here will get cancelled. Will get cancelled. So now what is left out? This is equal to what, dear students? R12 plus 23 plus 31 is equal to now R12 R23 into R31 whole divided by R12 plus R23 plus R31. This is important. Now just we will rearrange the terms. That's it. What we will do in this context, just we will change the value of brackets. Just we will change the bracket positions, we will change, and we will rewrite the terms. Now observe, this is same as, let me place bracket only for R12, 2, 3 into R23. Okay, into R23. But if you recollect, what is R1, dear students? From delta to star transformation we have seen. Observe R1. Now I will show you slowly. Observe R1 is R12 into R31 divided by R12 plus R23 plus R31. In this entire place, now what you can write? We can write R1. That is what we are doing here. Very simple. That is what we are doing here. Observe. Just you rearrange the terms. That's it. Enough. In this entire place, you are representing that with R1 into R23. Now you just separate R23 only. Therefore R23 equal to R1 into R2 plus R2 into R3 plus R3 into R1 whole divided by R1. So if you expand it further, or if you simplify it further, R1 into R2 divided by R1 plus R2 into R3 divided by R1 plus R3 into R1 divided by R1. So this is what? This R1 get cancelled. You will get R2. This R1 and this R1 and this R1 will get cancelled. You will get R3 and R2 into R3 by R1. This term remains same. That term remains same. So this is very, very important. Therefore, for a given star, if you want the delta value R23, it is simply, if you want R23, it is simply R2 plus R3 plus R2 into R3 whole divided by its remaining term. Similarly, if you are doing in terms of ABC, for example, RBC you want, it is simply what you can do, RB plus RC plus RB into RC whole divided by, what is the other one left out? RA. Very simple. If you are asked BC, RB plus RC plus RB into RC whole divided by RA. Very simple. So far clear, dear students? Similarly, we can do it now for 2, 3 is completed. Now we will do it for R31. You separate R31. For remaining terms, you place the bracket. Now whatever the thing that is there in the bracket, that is equal to how much? R2. Just from the first step we can say. Now R31 equal to R1 into R2 plus R2 into R3 plus R3 into R1 whole divided by R2 whole divided by R2. Now R31 equal to this R2 will get cancelled, and this R2 will get cancelled. So simply R3 plus R1 into R3 whole divided by R2. So R3 plus R1 into R3 divided by R2. Similarly, for the previous term, you rearrange the terms and you separate R12. Right? Step by step we are coming. 2, 3, 3, 1 and 1, 2. Whatever there in the bracket, that is equal to R3. Now your R12 will be R1 plus R2 plus R1 into R2 divided by R3. Very simple. For all these things, dear students, I repeat again, the basic step is step by step observe. First step is you write delta to star transformation. That is the first step. R1, R2, R3 write down. Clear? Next step, you just simply multiply R1, R2, R2, R3, R3, R1. You keep it aside, those three. Second step over. Third step, you simply add those three. R1, R2 plus R2, R3 plus R3, R1. That is the third step. In the fourth step, you just take out common R12, 2, 3, 3, 1. Okay, in denominator, one of the term will get cancelled out. Clear? So this is the main equation. Once you got that equation, just simply by rearranging the terms, easily you can find out R23, R31 and R12. Right? Yeah. Now let me summarize. This summary is important, dear students. Whatever problems are given or whatever intermediate stage you come across, if star is given and if you want delta, R12, for example, this is R12 value. Similarly, 2,3 value will be R23 value, and 3,1 value will be R31 value. If delta is given, if you want star, this is R1 value. Right? This is R2 value. This is R3 value. Just for understanding, of course you should not draw like this. Just for understanding sake, I am drawing like this. So now for the given star R12, okay, R1 plus R2 plus R1 into R2 divided by R3. Similarly R23, you remember like this, 2, 3 are there, no? R2 plus R3 plus R2, R3 divided by R1, R31 also like this. Similarly, if you want R1, you multiply these two, R2 you multiply these two, R3 you multiply these two, divided by denominator is same. This is the summary. Right? Now let me do a small example. Transform the given star to delta. Transform the given star to delta. In star, observe, dear students, here this is the first node and this is the second node, right? And this is the third node. First node we are having 30 ohms. R1 is 30 ohms. R2 is 40 ohms. Clear? R3 is 50 ohm. Now what about R12? If you draw it in the form of an equivalent delta, what will be the value of R12? We know from the star to delta and delta to star transformation formulas, our R12 is equal to R1 plus R2 plus R1 into R2 divided by R3. That is what we will do here. 30 plus 40 plus 30 into 40 divided by 50, and we will get that value as 94 ohms. We will get that value as 94 ohms. Clear? Good. Dear students, now I want to find out R23 in between nodes 2 and 3, in between the nodes 2 and 3, right? Its value will be R2 plus R3 plus R2 into R3 divided by R1. Clear? 40 plus 50 plus 40 into 50 divided by 30. We will get as 156.66 ohms. 156.66 ohms. Dear students, similarly R31 R3 plus R1 plus R3 into R1 divided by R2 equal to 50 plus 30 plus 50 into 30 by 40. We will get that value as 117.5 ohms. Very simple. So that means if 30, 40, 50 ohm resistors are there which are connected in a star manner, in delta they are equivalent to 94 ohm, 156.66 ohm and 117.5 ohms. 117.5 ohms. Clear? Good. Now let me transform just like in our delta analysis. In our delta case, we have done one example where I gave you 3 equal resistors of 3 ohms. In star, how much we got? 1/3 of that we got in equivalent star. That means we got 1 ohm, 1 ohm and 1 ohm. Now let me do the same kind of problem. If 3 resistors of equal value are connected in star manner, 10 ohms, 10 ohms and 10 ohms. Now if you transform it into an equivalent delta, what will be the value of RAB is how much, RBC will be how much, and RCA will be how much? That is the question, right? If I want RAB, okay, RA plus RB plus RA into RB divided by RC. In this context, RA is 10 ohms plus 10 ohms plus 10 into 10 divided by 10, right? And I will get that value as 30 ohms. And let me repeat the same procedure for RBC and RCA. RBC and RCA. Now RBC equal to RB plus RC plus RB into RC by RA. 10 plus 10 plus 10 into 10 by 10. We will get that value as, somewhere here it is wrong I think, 20 plus 30 ohms. This is 30 ohm and this is also 30 ohm. We will get that value as 30 ohms. This one also, RC also 30 ohms. Now observe, dear students, a value of 3 equal resistors connected in star manner, it became 3 times the value in star in delta. 3 times the value in star, value of star in delta. Now RAB is 30 ohms, 30 ohms, 30 ohms. So very important, dear students. Don't think that as star told from star to delta that value became 3 times. It does not mean that for example, some may misunderstand like this. For example, in star this is 5, this is 10, for example this is some 20, 5 ohms, 10 ohms, 20 ohms. As R told, it is becoming 3 times, so its answer will be 3 5s are 15, 3 10s are 30 and 3 20s are 60 ohms. Anybody think like this? We have seen some papers where students write like this. Because of that only I am telling. What they are doing is, whatever the values of given in star, they are multiplying it with 3 and they are writing the answer in a delta manner like this. We have seen some students expressing their answers in this manner. This is wrong. If 3 resistors are equal, then only it will be 3 times. If all the resistor values are different, you have to use these formulas and do the substitutions and do the calculation, then you may get the different values. Clear, dear students? Yes. If all the 3 resistors are equal in magnitude, then its equivalent value in delta will be 3 times the star value. If all the values are different, please don't multiply it with 3. You calculate on your you take a formula, do the substitutions, do the calculations, and then please find the final answer. Clear? So please practice more problems, dear students, right? With this we will start to delta transformation. Thank you.